Good morning. Today we are going to start the third chapter from paper first, that is the transducer. In last time we have completed the counter chapter from paper number 2. So we have started now the transducer chapter number 3 from paper first. Okay. So according to name the transducer, it transfers the energy in one form into another form. So this is the transducer. Then it transfers the energy from one form to the second form or another form. Okay, so energy is transferred. So energy is transferred by this transducer from one form to another form. The example is the transducer is like a mic. Okay, what mic does? Mic converts sound energy into electrical energy. Okay, so this is the mic. This speaker is also loudspeaker. So we know this speaker. The loudspeaker is also one type of transducer which converts the electrical energy into sound energy. Okay, so this transducer is nothing but which converts one type of energy into the another type. So mic converts sound into electrical energy, loudspeaker convert electrical energy into sound energy. So we studied about the LDR or light dependent resistor. Okay, when light incident on the LDR, it changes its resistance value. Okay, that means LDR converts light energy into electrical energy. What is electrical energy? Which is nothing but change in resistor. Okay, so this is also one type of energy change from light to the electrical energy, that is change in resistor. Thermistor is also one type of transducer. Okay, so thermistor which converts heat energy into electrical energy. What is electrical energy? That is also change in resistor. Okay, so the thermistor also converts heat energy into electrical energy. So all these are the transducers. Okay, so sometimes there is a very small difference between transducer and sensor. Okay, so this transducer and sensor both are nearly same, but there is very little difference. The transducer which converts one type of energy into another type of energy, but this sensor converts only physical energy into another form or electrical energy. Okay, so this sensor converts physical energy into electrical energy or into another form. Okay, another form of energy. Okay, but transducer only converts one type of energy into the another type of energy. Means we can say that all sensors are the transducers. All sensors are the transducers. What is the sensor? So there are 2-3 examples I have given here. So LDR is the sensor which senses the light. Okay, thermistor is also one type of sensor which senses the heat. Mic is also a sensor which senses the sound, that is physical quantity. Okay, but if we see, these all sensors are the transducers. Okay, all sensors are the transducers, but there are some transducers. If we say that these transducers are, example is like loudspeaker. Okay, so loudspeaker converts electrical energy into sound energy. Okay, which converts electrical energy into sound energy, but this loudspeaker is not a sensor, it is only transducer. So sensors are this one which senses the physical quantity. So sensors are this one which senses the physical energy, converts into the electrical energy or any other form. Okay, but here loudspeaker is not a sensor, it is a transducer. Okay, so as I said, all the sensors are the transducers, but all transducers are not a sensor. So we can, another transducer, if we say here the transformer is also a transducer. We can say that it is some kind of transducer because it converts high energy into low energy or low into high energy. It transfers the energy high to low or low to high. Transformer is also a type of transducer, but it is not a sensor. Okay, so these are the transducers. So we can say that all sensors are transducers, but all transducers are not a sensor. So these are also a transducers, but these are the sensors which convert physical energy into the electrical energy. So in your textbook some classification is given. Okay, so in your textbook some classification is given. The transducer, we said common word now here, transducer. Okay, or they may be exactly, it may be a sensor or it may be a simple transducer, but we commonly said that it is a transducer because, as I said, all the sensors are transducers, but all transducers are not a sensors. Okay, so classification of transducer, we just common name is a transducer, a device which converts one form of energy into the another form. As I said here, it converts one type of energy into the another form of energy. Okay, it may be physical energy into electrical energy or electrical energy into physical energy. Okay, so the transducer based on galvanometer which converts electrical energy into deflection. So this is a transducer, galvanometer. We know that galvanometer is just like a voltmeter or current meter that are having a needle. In 11th we seen about the electrical instruments. Okay, so galvanometer means there is just like a voltmeter. Okay, voltmeter which is having a needle deflection, we know that. Okay, galvanometer also is with a middle needle there is. Okay, it deflect on both these sides, but in a voltmeter the needle is on the left side. So if we apply a voltage to voltmeter, then what happens? The needle deflects. Okay, that means it is just a transducer. The voltmeter with a PMMC, we know that PMMC, permanent magnet moving coil. The voltmeter with the PMMC, if we apply a small current or voltage, the voltage is converted into the needle deflection. So it is a galvanometer type sensor. It is also type of sensor or transducer, okay, which convert electrical energy into deflection. Microphone converts sound energy into the electrical energy. Loudspeaker converts electrical energy into mechanical. So loudspeaker is also a type of transducer. Thermistor converts heat into resistance. It is a sensor as well as transducer. LDR converts light into resistance. So LDR is also a sensor. Quartz crystal, we will little bit discussed about this quartz afterward. To convert pressure into electrical energy and vice versa. The solar cell converts light into voltage. Okay, so quartz crystal also in 11th also we discussed about this quartz. strain gauge converts pressure into electrical signal. So there is some metals. If we stretch that metal, then it changes its resistivity, or it changes some electrical quantity. Okay, electrical characteristics. So that are the strain gauges. Okay, so one example is given in your textbook of the use of transducer. Okay, so there is a simple mic is a sensor which converts sound energy into electrical energy. So this sound energy is connected to the transducer. So it is a sort of transducer. So transducer means convert the small amount of electrical energy into high electrical energy. So this mic, okay, so whatever the mic converts sound energy into, it change some internal. Okay, let us we will discuss later on. So this mic converts sound energy into the some internal changes, and this internal change is converted into electrical energy by this transducer. So this is nothing but a circuit. Okay, so mic converts sound energy into some internal changes, and this internal changes convert this transducer into electrical signal, which converts this change into electrical change. That's why it is called as some transducer. Amplifier convert this small voltage into higher voltage, that is given to the relay. The main supply is given to this TV set. Okay, so then it changes the TV set on, turns it on or off. Okay, so this is just a simple example. Okay, not so important, just see, this is a example. Okay, so transducers can be classified in two types according to their activity and according to their working principle. Okay, so this transducer is classified in two types. One is a passive transducer and another is a active transducer. So passive transducer means what? So this passive transducer externally powered. So here written externally powered means what? So let us see here, passive transducer. Okay, so this is the transducer. It requires, so it is PT, passive transducer. It requires external voltage to operate. Okay, then this passive transducer converts one type of energy, say physical energy, into electrical energy. Okay, so best example of this passive transducer is LDR, light dependent resistor. Okay, when light is incident on this resistor, its internal resistance in ohm changes. When light is incident, its resistance decreases. When LDR is in dark, its resistance value increases. So this is a light dependent resistor, LDR. When light is incident, its resistance value changes. Okay, its resistance value changes. And how we are going to recognize the resistance is changed? How we can recognize the resistance is changed? The simple method is you have to apply a voltage to this LDR. Okay, and we are going to measure the current through this LDR. Okay, if light is incident on this LDR, its internal resistance value changes. As its resistance changes, the current through the LDR changes, because you are applied a fixed voltage V. Okay, so we know that I is equal to V by R. Okay, so I is equal to V by R. So this R is changes, and that depends on the light intensity. So change in resistance is nothing but change in a current. So like this we can recognize the resistance is changed. Okay, got this? That means if LDR is placed now, okay, so suppose this is LDR and this LDR is placed like this, and light is incident on this LDR. How you are going to recognize? We cannot see the change in resistance. Okay, we cannot see the change in resistance of this LDR. Okay, so but to change to recognize this change, you have to apply a voltage. As light changes, incident light changes, the resistance value changes, and this voltage is fixed. Okay, as resistance value changes, the current through the LDR is changes. So we can measure the current by applying current meter here, connecting current meter. If light changes, the current meter changes its reading. Okay, so this kind of sensor, the LDR is light sensor. So this kind of sensor is known as the passive sensor, passive transducer. It is a sensor, but we can say that the common word is transducer. Transducer and sensor both are same, well seen here. Okay, so this LDR is a passive transducer which requires external voltage source. So that is written here. So passive transducer means externally powered transducer which requires an external power to produce a change in electrical quantity like resistance, capacitance. There is also capacitance form. For example, thermistor, it changes resistance with the temperature, but electrical supply is essential to produce the current. Okay, so passive transducer. So thermistor is also. So this thermistor is also a passive transducer because if temperature changes, its resistance value changes, and this resistance value change can be recognized by applying voltage. Okay, so passive transducer means which requires external power supply. And there is another type is called as active transducer or self-generating transducer. Okay, so there is another type is active transducer. Okay, so this active transducer means what? It is a self-generating, means it converts directly one type of energy into the electrical energy like voltage and current. Okay, the main example of this active transducer is photocell. Photocell. Okay, so this is a photocell. When light is incident, okay, when light is incident on this cell, it directly generates the voltage. Okay, we know that there are some batteries available in the market which can be charged with sunlight. If we put that battery source light in the sunlight, then that get charged. Okay, because the photocell is used in that type of battery cells. When if we keep that battery in light, then there is a photocell panel. Okay, black colored photocell. Okay, the black colored photocell panel. When light is incident on that cell, it generates the voltage, and this voltage is used to charge the battery. Okay, this voltage is used to charge the battery. So this photocell is a active transducer which directly converts. There is another example is a thermocouple. What is thermocouple? So this is thermocouple. Okay, that means there are two joints. Okay, and these are used different metals, copper, okay, like that, and aluminium. So if this end is kept in a cooled and this end is kept in heat. Okay, so the thermocouple, if we apply a temperature difference, then current start to flow from high temperature to low temperature. That means if we apply a temperature difference, the current directly flows through this wire. It is called as thermocouple. Okay, directly heat is converted into the small current. Afterward, then we are going to amplify this current and we will get the conversion. Okay, so this is active transducer. So active transducer is a transducer capable of producing electrical variation when stimulated by some physical form of energy and which do not require external supply to perform the function. is known as self-generating or active transducers. Okay, the examples are given here. Thermocouple is a generating EMF across the junction of two dissimilar metals of semiconductors. When the junctions are heated, the piezoelectric. So another is a piezoelectric. So later on we are discussing about this piezoelectric crystal. If we apply the vibrations, it generates electrical signal, and if we apply electrical signal, it generates the vibrations. Okay, sorry. So we can also classify, it depends on the working. That is the mechanical transducer. There is some mechanical movements. Okay, if there is mechanical movement like strain gauge means there is a long wire. If we stretch that wire, it changes its internal resistance, and this change is used. Okay, there is simple wire, stretchable wire. Okay, if we stretch this wire, its internal resistance changes because of change in a cross sectional area. Okay, its internal resistance changes, that means this wire converts pressure into a change in electrical signal. So this is the mechanical quantity. LVDT, linear variable differential transformer, there is a mechanical changes. Okay, so this is mechanical transducer. Thermal transducer. Okay, so these transducers are based on temperature, thermistor and thermocouple. So the thermistor is a passive transducer, thermocouple is a active transducer, but their common type is a thermal transducer because these are related to temperature change. These give a response to temperature change. So this is a type of thermal transducer. So magnetic transducer. Okay, induction or surge coil. Surge coil means there is a coil. So we very well know that there is a metal detectors. Okay, in that metal detector such type of coils are used. That is called as magnetic transducer. Though there is a change in magnetic, there is change in some magnetic field because of change in its induction. Okay, so it is a magnetic transducer. Radiation transducer, phototube, photodiode, photocell, these are the radiation, LDR, light dependent resistor, these are the radiation based transducer. So we saw the working of the transducer, classification of transducer according to the activity. Okay, so this according to the activity means it is the passive transducer and the active. So this is the main two types. So this classification is according to activity, and according to the working principle means, so this is the according to the working principle: mechanical transducer, thermal transducer, magnetic transducer, and the radiation. There are other different types, but we are considering only these four. Depends on the mechanical depends on the working. Okay, so if we are going to design a one circuit or a one system based on transducer, okay, if we are going to design a one type of system, okay, in that we are going to select a type of transducer. Which type of we are going to select, there is some criteria. So we follow this criteria, and depends on that we are going to select the transducer. Okay, you very well know that if we want to measure a temperature, so we have to choose a thermal transducer. There is no meaning to choose a mechanical transducer or magnetic transducer. This is a simple common sense. Okay, if we want to measure a temperature, then you have to select a transducer type. Which type of which type of quantity you are going to measure? There, suppose temperature, then you need a temperature transducer, thermistor or thermocouple. There are two options. We can select one of them. Okay, so first criteria to select a transducer is a transducer type. Okay, so this is a transducer type. So you are going to select the type of transducer which you are going to measure. Okay, if you want to measure light intensity, then you have to select a light transducer like LDR, okay, or like photodiode. So these are the radiation type transducers. if you want to measure a temperature, then you have to select the thermistor or thermocouple. So this is simple thing. This is a transducer type. The first criteria is a transducer type. So what you are going to measure, according to that you have to select a transducer. Okay, that is the first criteria, is you have to select the transducer type. The second criteria is the transducer specification. Okay, so if we select a transducer and we want to fit in the particular cabin, so in that case you have to see the size of that transducer. Okay, so what is the size? This is the nothing but a specification. So you have to consider the specification also. Okay, suppose you want to measure a temperature in a small cabin. In that case you have to select a temperature transducer so that can be fit in that particular cabin. So this is the one of the criteria, the size. What is the size of that thermistor or thermocouple? So you have to select that. That is nothing but a specification of the transducer. The specification of transducer is like a size, package type, diameter, height, or so on. Okay, so these are nothing but the specifications. Or also you can consider the operating range. Okay, suppose one sensor is used to measure some quantity in a very high temperature. So you have to choose that particular transducer that can be operated with that high temperature. Okay, and suppose there is some condition you have to measure that particular quantity in the low temperature. So in that case you have to select the temperature range of that transducer. If you use the transducer which is operated in high temperature and which is you are used to measure some at the low temperature, then it cannot give a perfect result. So that you have to select a transducer by considering its specification. In that specification you have to consider the size, type, diameter, height, and so on. Okay, there may be some operating temperature range, sensitivity. What is the sensitivity? Okay, suppose the sensitivity means what? Suppose you want to select a spy camera mic. So in that case you have to select a mic with a high sensitivity. That mic is not we are not going to use the mic which is used for the public address system or for this speaking purpose. So you have to select that particular high sensitivity mic if you are using in that spy gadgets. Okay, so you have to consider the transducer specification. Second one is transducer compatibility. Okay, so compatibility means if we fit that transducer in a particular system, in that system it should be operated. Okay, in that case you have to consider the acceleration, shocks, vibrations. Okay, if the one transducer is used for a stable condition, okay, it is not used in a running in motion condition, then that transducer is not able to apply for that moving condition. Okay, if you are using any sensor in the cars though, so you have to use the sensor so that it can be tolerate the accelerations or shocks of that car. Okay, so like that you have to choose a compatibility, means if that particular sensor is operated in a particular the environment, you have to also see that is nothing but a compatibility. Okay, if there is some specification, I told the temperature, so it is also coming here also. If you see the temperature range, acceleration, shocks, or vibrations, these are nothing but the compatibility of that transducer. Okay, so there should be compatible. If some sensor is used in a motion and some sensor requires in a stable condition, so like that you have to choose the transducer depends on the compatibility, or it has the impedance. There should be, you have to select some transducer for a particular system. In that case you have to select the impedance of that particular transducer. Suppose means there is a thermistor which is having a 5 ohm. Okay, 5 ohm resistance, and another is also thermistor which is having 1 kilo ohm resistance. Okay, but 5 ohm or 1 kilo ohm resistance both are having same that are used for the temperature measurement, but we are going to select a circuit in which that is fitted. Okay, 5 ohm resistance, 5 ohm thermistor is required at that particular circuit which can be tolerate the 5 ohm resistance, and 1 kilo ohm resistance thermistor requires a particular designing of that circuit. So you have to see the compatibility also. So this resistance also matched with the system. Okay, one system is designed for 5 ohm thermistor, then you have to use that particular. If one system is designed for 1 kilo ohm, then you have to use that type of thermistor. Okay, so this is the selection criteria of transducer: transducer type, transducer specification, transducer compatibility. Okay, so just look at this. We are going to stop here now.